Hello everyone and welcome to the practice video of a limit of a function, but this is about what? Evaluation by graphing. So don't worry, there's no true or false here. It's more about graphing. Okay? It's more about graphing here. Okay? So without further ado, let's now begin. Alright, wait. There you go. What is f of 0? So our input here is 0, right? So we have a 0 here. And our y value, it's actually from here. Why it's here in this graph, which is -1. So the answer is -1. Now, how about the limit of the function as x approaches 0? Okay, no problem. Okay, so x approaches to 0, right? So here's a 0. Now, let's start from the left. Left going to 0. So -1. So -1 approaches at this value, which is -2. Let's get closer to 0. So from here, getting here, it gets closer to this point. It doesn't state actually what's the point here, but I think you get my point. Now let's get even closer to 0, which is this one. So as you can see, it's getting closer to -1. So if we let this one gets closer to 0, so it's getting closer to -1. So here, as our x approaches 0 from the left side, it's approaching to -1. Now, how about on the right side? How about on the right side? Hold on the right side. So let's use red. So let's start with 1. Okay. So here it's undefined. So no. How about 0.5? I guess 0.5 is here. So here, the y value is actually here, which is, I do believe it's -0.5, I guess. Okay. Now, how about we get closer to 0? Okay. So it's here. Okay. It's here. Getting closer to -1 as well. So if we continue this one further, it will get closer to -1. So as x approaches 0 from the right side, it approaches to, no. Sorry. It approaches to -1. Therefore, the answer here is -1. Okay, the answer here is -1. Okay, the answer here is -1. Okay, how about this one? Wait, -1, -1. F of 1. So here, since in f of 1, right, this is your input, right? So it's 1 here. But you see, we were about to put 0 as our answer, but we have a hole. So this is undefined. So no, we can't. But what if we find the limit of that function as x approaches to 1? So let's just say we start with the left side. So we start from 0, we get -1. How about getting closer to 1? So we have this, okay? Which is getting closer to 0, I guess, okay? Let's make it even closer to 1. So here it gets closer to 0. And we made it even further, it gets closer to 0. So meaning, as the x approaches 1 from the left side, it approaches to 0. Now, how about on the right side? Now, on the right side, okay, let's just say we start at the x value of 2. So 2. 2 is, 2 is here, and the y value of it is 1. It approaches to 1. Now, how about we get closer to 1? Okay, x value. So this one, let's just say this is 1.5. So 1.5, 1.5's y value is here. which is, as you can see, it also gets closer to 0. So let's make it even closer to 0. So we will have a y value of this one, which is also getting close to 0. Okay? So here, the result would be what? 0. Because as our limit of a function approaches 1 from the right side, it approaches to 0. Therefore, your answer is what? 0. Okay? Since both of them do approach to the value of 0. Okay? Now, next. How about this one, though? Oh, wait. All right, there we go. We have it already. What is f of 1? So here, your f of 1 is your input of 1 is here. If you're going to find f of 1, the answer would not be 2 because here, in this part, it's a whole. So it's undefined. Okay, it's undefined. So meaning there is no value here. Okay. However, at this value, this one is shaded. So that means this is defined. So your one is defined at this point, which is actually 0.5. Okay, this is 0.5. Okay, I think I miscalculated the graph. So this is 0.5. So therefore, your answer would be 0.5. Now, how about finding the limit of it? Finding the limit of a function as x approaches to 1. Let's start with the left side. Okay, left side. So from, let's just say 0. Okay, let's start with 0. 0 is here. Now 0.5 is here. And if we get closer to 1, it's still here, exactly at 2. It's still 2. So if we let our x value closer to 1 from the left side, it gets to what? A value of y value of 2. So from the left, it is 2. But how about on the right? Okay, how about on the right? So on the right, let's just say I will use a blue color. Let's just say we start at the 2. Okay? 2 is here. If we go further, like 1.5, so the y value here is this one. Okay? This one, which is actually uh, almost close as 2. Now we get even closer to 1. So we have this one. So we have this. Let's get, it gets the y value of closer to 1 here. Now let's make it even closer to 1. Okay? So slowly, we're approaching to what value? 0.5. Okay? As our x values approaches 1 from the right side, it approaches to 0.5. So our right is 0.5. It's 0.5, guys, okay? Not 3, 0.5. Now, if you're going to take a look, left and right are not the same. Therefore, the answer would be D and E. The limit does not exist. Okay? Next. How about this one? Okay? Here, let's find the limit. No. Function first. F of 1. So here in f of 1, if you're going to observe, 1 is here, right? Yeah. And you see, there's a hole in here. So again, if it's a hole, it's undefined. No. But take a look. At 1, you see there's a hole here. No, not a hole. Rather, a shaded point here that is actually what? Defined. Okay? So in here at 1, we have undefined y value and a defined y value, which is exactly at 2 units. Okay? So therefore, f of 1 may not be defined at 0 because it's a whole, but it is defined at this point, which is at 2. Therefore, your answer here is 2. Okay, the answer here is 2. Now, how about we find the limit? Okay, how about we find the limit of this function? So, okay, no problem. So let's start from the left. So on the left, let's just say start from here. So your y value, let's start from here. So your x value here, okay, it approaches to this y value. Okay, let me erase this one. Okay, which is basically close to negative 1.5. Now, how about this one? Gets closer here to the x value of 1. You will have a y value of closer to negative 0.5. Now, if we get closer here, you get closer to 0 and 0. So therefore, on the left side, it approaches to 0. Now, how about on the right side? Let's just say we start at 2. 2 is actually here, yeah, and it has a y value that is close to 1, but far from 0. How about this one though? Okay, the y value of this, okay, it's close to the midway of 0 and 1. Now we get closer to 1 as your x value. Your y value gets closer to 0, you know? So that means as our x values gets closer to 1, it approaches to a value of 0. Therefore, the answer here is 0. Remember, again, in limit, it's not about exactly. Rather, it's about approximately. Okay, as it gets closer and closer and closer and closer. Okay, so the answer is 0. Okay, okay, we have one more. So here, wait. All right, there we go. So here is our last problem. Wow, it's complicated, but don't worry, we can answer this one. Okay, let's find f of negative 1. So we have an input of negative 1. Negative 1 is here. So negative 1 has two values, either here, which is exactly 1, or here, which is exactly 2. So you have two y values. But, however, you see, at this point, it's a whole. Therefore, it's invalid. But we have a shaded region, which is still at negative 1 as your x value. So here in the shaded region, your y value is 1. So therefore, your answer here is 1. Okay? So let me explain it one more time. Here in your input negative 1, you have two y values. We have this one, the shaded, which is 1, and the whole, which is your 2. We cannot let 2 as our answer because it's invalid. However, here it's shaded, so that means it is valid or defined. So we can have 1 as our answer here. But let's find our function here as x approaches to negative 1. So that wouldn't be a problem actually. Okay? So approaches to negative 1. So let's just say we start at 0, negative 1.5, which is here. That's so far. Let's just say here. Okay? Here. Which is, it approaches here. Wait. The y value is here. It's here. So the y value is actually closer to 3. Now, if we get closer to negative 1, okay, we will have a, hold on, we will have a y value, this one, okay, this one, which is close to the midway of 2 and 3. But you see, if we get closer to negative 1, okay, what happens? It approaches to here, which is the value of 2. Okay? So therefore, your left is equal to 2. How about on the right? So on the right, you know what? I'll just draw a line instead of a dotted line. But yeah, so on the right, let's just say we start with 0. So 0. So your y value is still 0 because it is actually on the same position as the origin. So 0, 0. If we get our values closer to -1, let's just say from here, so our x value here, let's just say it's 0.1 or 2, and the y value here, maybe it's greater than 0. I mean, sorry, less than 0. This is actually negative 0.9, sorry, 0.1, 0.1. So the y value here, uh, it's greater than 0 because as we get further and further, like from here, let's just say approximately this is negative 0.6. So your y value is here. So that means it's getting a y value greater than 0. So let's just say here, you have a negative x value here, getting closer to -1. So this one, you will have a y value here, which is closer to 1. But if we let our x values getting closer to -1, as close as we can, we're actually approaching to what? We're actually approaching to 2. So therefore, your right side approaches to 2. So since both sides approaches to 2, so therefore our answer is 2. Okay? Now, let's go to the second problem. Find f of 0. So your f of 0 here, your input is, yeah, it's 0. So it's here. Okay? Which is, it's exactly 0 as well, you know? So therefore the answer is 0. Now, how about as x, limit of this function as x approaches to 0? So let's just say you start from the left side. You start from here, -1. So from -1, it approaches to 2. Now, if we get closer to 0, this one, it approaches to almost 0.25. And it, as we have x values gets closer to 0, so here it gets closer to 0 actually. So here on the left side, it approaches to 0. Now, how about on the right side? So let's just say you start at +1. So +1, your y value would be 2. It's 2. Now, if we get closer to 0, your y value would be closer to 1 or midway to 1 and 0. And if we have a x value here closer to 0, your y value gets closer to 0. So they both approach 0. Therefore, the answer here is 0. Okay? It's 0. Now, what would be the answer on the last problem? Okay? Hold on. F of 1. What is f of 1? So your f of 1 is here, and you have two y values. This one, which is 2, exactly. And this one, which is this shaded part, and it's 3 exactly. You see, you have two y values, but here's the problem. Your 2, which is a part where the hole happens or the hole is located, it's undefined. So no, we cannot have this as our answer. But, however, on the 3, it has a shaded portion of it. Okay? It's shaded here. So therefore, f of 1 is 3. Okay? Now, how about we find the limit? The limit of function as x approaches to 1. Let's start from the left side. So 0, it still have 0. Let's just say here, if we have our x values closer to 1 from the left side, we have a y value here. So this would be, okay, closer to 0.5. Now, if we have values here, so here we have y value greater than 1. Oh, okay. Now, if we get closer to 1, it gets closer to the y value of 2. So that means as our x values approaches 1 from the left side, it approaches to 2. Now, how about from the right side? So on the right side, so let's just say, wait, I'll erase this one. So let's just say you started 2 here. 2 is actually here, which is exactly at 3. So if it's, let's just say, midway, 1.5. So 1.5 is here, which is closer to 3. So we let our x values closer to 1 from the right side. So the answer is still 3. So that means as we let our x values get closer to 1 from the right side, the answer is 3. And both of them are not the same. So therefore, your answer here is D and E. The limit does not exist here since both of them are not the same. And there we go. We're done. So the next topic we're going to discuss is one-sided limits. Okay? So that will be all, guys. So see you soon in the future.